So we have these two warm-ups that we started with. So these were very similar to the questions we were dealing with yesterday. So looking at the first one, what did you want to do first? What was your first inclination? Distribute. So we have that 4 outside our parentheses. So as soon as we see parentheses in any type of equation, we always want to distribute first. So we got to multiply that 4 in there. And so we get 17 equals 5. We can copy that down from above. And then 4 times 2 is 8x. And then 4 times -3 is -12. Very good. All right, from here, what should we think about doing? What was that, Wade? Like terms. What like terms do you notice? 5 and -12. So I can combine 5 and -12 to give me -7. So I have 17 equals -7 plus 8x. You could have also written this as 8x minus 7. It's still the same thing, still the same equation. We just combine that 5 and that -12 into 7. Two-step equation, where do we go from here? Rod?
You add 7 from both sides.
Add 7 on both sides, awesome. So I need to inverse my constant right here. So right now it's a negative, so I'm going to add it. If I add 7, that gives me 24. So 24 equals what we have left over is just 8x. And then our last step, inverse our coefficient, divide by that 8. Divide by 8. We have x equaling. Very good. So once again, just running through those main steps again. We always want to distribute first. Anytime you see those parentheses, get rid of them. Just distribute. Then from there, we want to combine those like terms into a single answer or to those single values of those single like terms. Inverse that constant, inverse that coefficient, and you're good to go. One thing I noticed from a few of you is when you got to 5 plus 8x minus 12, we wanted to inverse each of these two numbers separately. And that's fine. You'll still get the right answer by subtracting 5 and then adding 12 separately. That will still get you the right answer. But the thing is, rather than combining them into a like term, if you had a lot more of those, if you had plus 13, minus 11, plus 84, and we had to inverse every single one of those constants, it would add up a lot of extra steps that we just don't need. So by simplifying it to a single term and then inversing it once, you're eliminating some extra steps that just sort of take up extra space. And so always try to combine those like terms first before you start inversing those constants and inversing those coefficients. Are we okay with this?
Yes.
What did we find for our second one? That's the second equation. Lauren? X equals 4.5. Good. That should be right. Does anyone have any questions on where we came up with 4.5, or does anyone want me to walk through the steps on this one? Okay. It should be the same exact process. You should distribute, you should combine like terms, inverse your constant, inverse your coefficient. The only thing different is your numbers. So we're all good with the warm-up? Awesome. Cool. All right. So let's see. Yesterday we did do this problem, correct? We ended at the end of the day. Okay. The other classes didn't quite get there today, or didn't quite get there yesterday. They did today. Once again, though, one of the things as we continue on is we're going to look at these word problems. We're going to look at how can we read those word problems to figure out what are the equations. How can we build the equations from those specific words? So being able to identify the word result or is, and being able to identify, oh, that's my equal sign. Or knowing added is addition, or knowing that times is multiplication, or when you see something split up among groups, knowing that it's division. And just being able to identify, that's something we'll continue to work through throughout the whole year and to prepare you guys for that upcoming state test, because that's the big thing they like to do in the state test. Do we have any questions about this problem from yesterday? I know we ended at the very end of class yesterday with it. Do we have any questions from there? Okay. So once again, the main thing was just being able to read the question, create those two equations, and then once you found the one, being able to plug it into your other equation to be able to solve. So we'll only look at a few questions today as group. We're a little bit ahead. Looking at this, what do you notice about either of these problems? Kevin?
2 parentheses and 2 variables.
All right, so we have two parentheses, and in each of those parentheses I have variables. So I got a lot of stuff going on here. Can I deal with two parentheses? Can I do anything with that, or do I just give up? Okay.
Distribute both.
I can distribute both of them? Okay, how would I go about that? What would you do if you were solving this problem? What do you want to do first?
6 times 2.
Okay, 6 times 2.
6 times 3x.
Okay,
Negative 3x.
so 6 times 2 is 12. 6 times negative 3x is negative 18x. Okay, so I got my first one.
And then 4 times 1.
Which is 4.
And then 4 times negative 1.
4 times negative 1x. And once again, if you forget, we can always just write in that little negative 1 in there, or that little 1 sitting in front of the x and it doesn't have a number. If it confuses you on what number in front of there, just remember to put in that little 1. And so that gives us a negative 4x. What operation should I put in between my negative 18x and my 4? Positive, because I have that little positive 4 there, so I can put a positive sign in front. And from here, equals 28. Negative 28, sorry. From here, you can always get rid of all of those parentheses just by distributing. It might take you a little bit longer to do multiple distributes, but it's okay. We can write down the whole solution, and then from here we can go into our combining our like terms, inversing our constant, and just combining all that to give it simpler. So what like terms do you notice when you look at this? What like terms do we have?
12 and 4, 12 and 4,
All right, 12 and 4
and negative 18x and negative 4x.
here. So we have 12 and 4, which we can combine to 16, and then negative 18x and negative 4x, because they're variables and both have an x in them, we can turn into a negative 22x. We combine both of those together. Negative 18 and negative 4. And this whole thing equals negative 28. Are we okay with that distributing and combining like terms so far? Just a little bit extra work, but nothing we can't handle. And then from here, we're back to our two-step equation that we've been doing for a week now, that we're getting bored over. Inverse our constant. Negative 22x. Negative 28 minus negative 22 should give us negative 44, because it's a negative minus negative. We're going deeper, deeper, deeper into those negatives. And then last thing, we have our inverse our coefficient of a negative 22. Once again, we want to make sure we pull that negative with the number. The negative is attached to the number, not necessarily the variable. And so negative 44 divided by negative 22 leaves us with an answer of positive 2. And that is your solution. Are we okay with this episode that we took to get this problem? All right. See if you can mimic those. See if you can try again with that second one. Some things I noticed from the other classes, a lot of students were dropping off at negative in front of the 44, so just watch out. It's negative 44, not just plain 44. What do we find for the solution of that? X equals 4. So once again, using those same steps that we just went through, we distributed. We had to distribute twice. Once again, are you okay, Sam? Do you want us to walk through it? Okay. So let's walk through this and let's see what we did. So step number 1: whenever we encounter those two parentheses, we should always distribute. That means for both of them, we always want to distribute twice in this case. So that means 5 times 1 is 5. 5 times negative 2x is going to be negative 10x. 3 times 2 is 6. And then 3 times that negative x. I expect it to be a negative 1x because there's that hidden negative 1 in there. So that's going to be 3 times negative 1 is negative 3x equals negative 41. And from here, because I had an addition in front of my 3, I can keep my addition step here. Are we okay so far? Okay. So from here, now that we distributed, we got rid of all those parentheses, we can start combining those terms, we can start grouping those like terms together. So what like terms do we have? We have negative negative 10x and negative 3x. So both those are like terms, so I can combine that to a negative 13x. And then I also have my 5 and my 6, which I can combine to an 11. So I got my negative 13x plus 11 equals negative 41. And from here, after we distributed, combined our like terms, we're down to that simple two-step equation, inverse the constant, inverse the coefficient. So I can subtract 11, that cancels out, and that gives me negative 13x equals negative 52, because I'm going deeper into those negatives because they're both negative. And then last step is divide by that negative 13, divide by negative 13, and we get x equals positive 4. You found your mistake? Okay, good. So once again, distribute all those parentheses if you can, combine those like terms, inverse that constant, inverse the coefficient, and you're good to go. We're going to look at one last question for this note to finish this out. So I have 3x plus x plus x plus x minus 3 minus 2 equals 7 plus x plus x. I feel like a broken record. In this equation above, what is the value of x? Looking at this monster here, what do you notice? What was that? What way? Lots of variables. We have a lot of x's on the board. What else do you notice? We are some numbers. I'm going to write it bigger. Try another one in there. Minus 3 minus 2 equals 7 plus x. Anything else we notice? Is the coefficient? Where underneath the sun? What do you notice on both sides of that equal sign? We have x's on both sides. Typically, so far, we've only been dealing with x's on one side of the equal sign. We've only been dealing with variables on one side. But on this one, we have variables on both sides of our equal sign. So we're going to have to figure out how can we deal with variables on both sides. You've probably been introduced to this in the past. You've probably seen these last year. I know when we put this problem up on the board during the first period, they're like, oh, I hate these types. And so this is going to be the main thing we're going to deal with a lot. Next week is having those equations with equal sign or variables on both sides of the equal sign. And how can we deal with those? But this is a lot going on right here. That's a really long problem. How can I simplify this and make it a little bit nicer to write? One, like terms. All right, so I got a bunch of x's up here. Those are all like terms. So I have 3, 4, 5, 6 x's. I have two constants on my left side, a negative 3 and a negative 2 that I can combine together. Gives me a negative 5. On my other side of the equal sign, 7 doesn't have any other like terms with its sign, so I'm just going to leave it at 7. But x and x can both go together to be a plus 2x. So hopefully, combining all those like terms makes the problem look a little bit more bearable, a little bit less intimidating when we get rid of half those x's. But we still have x's on both sides. We still have x's on each side of our equal. Lauren, what's your thoughts?
You have to bring like the 2x over to the other side.
So bring it over to the other side. How can I bring it over to the other side? Sophie. So just like how we would inverse a constant to remove it from one side, or inverse a coefficient, we can inverse our variables as well to move them. So I can inverse this by subtracting 2x. So if I subtract 2x from one side, I completely remove my variable from this side. I completely remove my 2x. And if I remove my 2x from that side, I have to move it over to my left side. Because as soon as I do an operation to one side of my equation, I have to do it to the other side, even if it includes a variable in it. I want to write it with a 6. I want to write it with a 6x because this has an x in it, this has an x in it. I can only operate with like terms, so I can only use those operations with like terms. So I know it has to go with the 6x. It can't go with a 5 because the 5 is a constant. This gives me 4x minus 5 equals 7. So I inverse my 2x. Now I'm just back to that single variable, single two-step equation that we're familiar with, that we know how to do. Inverse our constant. We get 4x. Oh, goodness. Sorry about that. We have 4x equals 12. Inverse 4. Inverse our coefficient, which gives us x equals 3. So even though we started with a big bunch of stuff at the very beginning, we started with all of those x's, as soon as we can combine those like terms, it makes it a little bit simpler, it makes it a little bit easier. And then from there, we can inverse those variables. We always want to get all the variables to one side. We don't want to have variables on both sides just sitting around. We always want to push it over to one side. Would it have changed if I had inversed my 6 instead and moved 6 over here? Can I do both ways, or do I have to do the x, or do I have to do the 2x? Okay.
You can do both ways.
Okay. So we can do it both ways. Why was it better to do the 2x though? Why did we choose the 2x? Does it make a difference at all?
Because it keeps the variable in its coefficient positive.
Good. So if I had subtracted 2x instead, or if I had subtracted 6x instead, if I removed 6x, I would have to minus 2x minus 6x, which would give me a negative 4, or a negative 4x. So you can do it either way. Either way would still get you with all your x's over on one side, but it's typically easier to work better with positives. And I'd rather have a positive coefficient to deal with. And so by removing the smaller variable, you're going to leave those coefficients almost always as positives, which will make it easier to work with. So always, general rule of thumb, if you see a smaller coefficient, move that one to the other group. Very good. You guys did awesome on that. All right. So cool. We're going to take a little bit of time to practice. I have some practice that you can work on this individually. You can work on this in your groups together. Some of them are about the same level as what we've been working on. Some of them are a little bit above the same level of what we've been working on. If you run into a question that you're concerned with, that you're like, oh, I don't remember seeing this error before, you might not have seen it before, call me over, let me know, and I will try to reason with you to help work you through it. But this is practicing those skills, making sure you can get this down. Once again, we're to work more with stuff like this next week, with having variables on both sides. That's going to be our main goal for next week. And then our assessment's going to be on that Friday. So I will hand out this practice, and you guys